in 1.0 for solving equations for geometry, and essentially this is a review of the content that was covered in Algebra 1, but we will be solving equations in geometry, and so we're going to be reviewing this content. So the first thing to do with the lesson is to go ahead and color in these tiles. And so just color them the same colors that you see there, blue, red for those, yellow for that. And feel free to pause the video, get it colored in, and then unpause when you're ready to proceed. Okay, so for these tiles, we're going to be using these rectangular tiles as variable tiles. And the coloring, a red tile represents a negative tile. If it's not red, it's a positive tile. So this blue tile represents positive x, and this red tile represents negative x. And the square tiles represent ones. This would be a positive one, this would be a negative one. So an important part with that, if I have a positive one and a negative one, they will combine to make a zero. We call these zero pairs. And here you have a positive x and a negative x. They will cancel out and make a zero as well. And that's going to be important for what we're doing. Now the reason we're using algebra tiles is we're trying to establish the concept of solving equations, to give us something physical that we kind of see and work and manipulate with. So it's not just a bunch of abstract letters and numbers that, that may or may not make sense. And so that's really kind of the purpose in it. One of the things we want to establish is this idea of flipping tiles. Now, when we flip tiles, it means that we turn over the tiles when we flip them over the equal sign. So when I say flipping, that we're going to be flipping tiles, that means we're literally turning them over as we flip them over the equal sign. And I'll give you an example of that. And so here's an example of an equation that we're going to solve. We're going to use it using tiles. And this is kind of my work for it. So I'm going to have this sheet out here to put my tiles on. Let's see if I can move this up just a little bit, just so we can see both of these at the same time. And I'm going to go ahead and build this equation. It starts out with 2x minus 5 equals 3. Now our x tiles are the blue rectangles. So here are 2 x tiles, because it says 2x. So those are our 2 x tiles. And then it says minus 5. Now when you see a minus, you're going to treat that as a negative. A minus 5 would be 5 red tiles. If these were yellow tiles, it would be plus 5. So here's our 2x, here's our minus 5, and that equals 3. And so it's a positive 3, so these are going to be yellow tiles. Now here is what we're talking about as kind of our process for solving. Our goal is to get these rectangle tiles by themselves. In fact, we only want rectangles on one side, and all the little squares need to go on the other side. So that is kind of what we need to do first for our initial goal. And so I don't want these square tiles with these rectangle tiles, so I need to put them over here. And this is where flipping comes into play. When you move tiles from one side to the other side of the equal sign, you flip them. So I'm going to take all 5 of them and I'm going to flip them over. So what we wind up is we have 3 tiles here, the original 3, and now these ones that we moved from this side over to this side, they flipped, and now they're a positive 5. Now our next step is we can combine. Well, if we combine all these together, we can see that we have 8 tiles. So that's where the 2x equals 8 comes from. So that's all we did. So we flipped these -5's over to this side, they became +5. And then we combine these together. And since they're both positive, I call that an alliance. They're on the same team, they team up into a bigger group of positives. And then the last part is we need to figure out, okay, well, how much is each x? If this is equal, how much is each x? How many tiles does each x have to be equal to for this to be true? Think of these as children and these as cookies. You need to divide up the cookies among the children. So we'll put our 2 kids here, and then we'll start dividing these cookies among the 2 children. And we can see if we divide them evenly, each child gets 4 cookies. And that's what we have here. We divided these into 2 groups, so you are literally dividing as your next step. And you always divide by what's in front of x. Whatever's in front of x, that's what you divide by. And then 2 divided by 2 is just 1, so you just have 1x. You don't have to write the 1, and x implies 1x. And then 8 divided by 2 is 4. So we can see that each x corresponds to 4. So we really did 3 steps here. And let's go ahead and write what those steps are. Step 1, flipping. And then we flip tiles over the equal sign. The tiles change signs when flipped. Right? So just like over here, when we flipped these 5, they were negative over here, right? When we flip them, they change color, which means they're changing sign. Right? Step 2, what I call combining. And these are either wars or alliances. Now in our situation, we had the same type of tiles that were the same color, like they wear the same uniform, right? So that means they're on the same team. This is an alliance. They're going to team up and join together. Now, what if we had a situation where we had, let's say, 6 positives and 2 negatives? This is no longer an alliance. They are not on the same team. They have different uniforms on. So this is a war, and they're going to fight it out. And this is where the 0 pairs come in. 1 negative takes out 1 positive. And this negative takes out 1 positive. So these wind up creating 0 pairs. In other words, they cancel each other. And then you're left with 4 positives. And so when you get to this second step, you have to look at each side of the equation and ask yourself, do I have wars or alliances? Are they all the same color? Are they all wearing the same uniform? If they do, just combine them together. And if they are different, then you have to fight the wars by pairing up a positive and a negative, right, to create these 0 pairs that can then get pulled off. And whatever you're left with winds up being your answer. All right? And then step 3 is dividing. And then we divide both sides by by whatever is in front of x. So In this case, it was a 2, so it was 2x, so we divided both sides by 2. If this had been a 5, we would divide both sides by a 5. If this was a -7, we would divide both sides by -7. In the division step, you always divide by what was in front of x. All right, let's go and turn the page. Okay. So for the next one here, I am going to work this one using tiles again. So we'll build our tiles. This time we have x's on both sides. And so we have 4x here, so I'm going to go ahead and put 4 of these rectangles here. These are positive, so they stay blue. If they were negative, they'd be red. And then it's just a plus a 1. So that is 4x's plus 1. Over here we have 2x's. And this is -5. So these are going to be 5 negatives. Remember, a minus sign or subtraction sign is treated as a negative. So, once again, our goal is to get all the rectangle tiles on one side and the square tiles on the other. So I think it'd be easier to take these rectangles and move them over here, and take this tile and move it over there. But we don't move them, we flip them. Anytime you're moving across the equal sign, you are flipping. So I'm going to take these 2 x's, I'm going to flip them to this side. And I'm going to take this 1 and I'm going to flip it to this side. So what have I done? What have I created? Well, I have 4 x's, and then I have 2 negative x's, so -2x. Right? That's 2 x's, but they are negative x's, so you need that subtraction of that minus in front. Over here, I still have the -5, but then I flip this over, and this would be plus a -1. Now, I want to put a note, -5 minus 1, and -5 plus -1 are the same. There's no difference in the answer that you get with that. Let me grab a calculator and show you. Okay, so I have a negative, I'm going to zoom in on this so you can see a little bit better. I have a -5 minus 1, that is -6. And then I have -5 plus -1. Right? So that's what we have here. Oh, that is not a plus, sorry. There we go. So -5 plus -1, also -6. So these mean the same thing. So when you have a plus minus, you treat it as a negative. So as I look on this side, is this an alliance or a war? Well, if I look at my algebra tiles, this is clearly an alliance. They're all red, right? So we have 5 negatives and we have 1 more negative. So these are on the same side. They're the same team. They're all wearing the same uniform. So this can get combined together to make 6 negatives, or -6. What about this side? Is this an alliance or a war? Well, this is definitely a war. If you look at the tiles, the colors are different, blue and red. So they're going to fight it out, and all I have to do is pair up a positive and a negative x, and they cancel each other and get put off the mat. So what are we left with here? 2 x's. This was a war. The signs were opposite, the colors were different, right? They had different uniforms on, so they're going to fight it out. There were more positives than negatives, so the positives win. And now we're going to do our last step. I need to find out what x is, but I have 2 x's here, so we're going to divide these up, and then we're going to take these tiles and divide them between the 2 x values. So now we can see that each x corresponds to -3. Now how do I do that algebraically? Well, division, you always divide by whatever's in front of x. So 2 divided by 2 is just 1, so you're just left with an x. -6 divided by 2 is -3. And that winds up being your answer. Okay, So I've done a couple with tiles, and the purpose of tiles is once again to give you that visual and something that you can move. So it really helps us to get a conceptual understanding of solving equations. But on this last one, I'm not going to use tiles for it. I'm just going to use the basic principles. First one, flipping. Right? Step one is flipping, and you want to flip so that only x terms are on one side and numbers, things without x, are on the other. Well, I have a 2x here, that's fine, but I have this x over here, this minus x, that's on the wrong side. I need to flip it over here. Well, when you flip it, it changes sign. It becomes plus x. Over here we have our 5, but on this side we still have this negative 4. We haven't done anything with it. It would still be here on this side, except I'm going to take this negative 4 and I'm going to flip it. And when I do this, this becomes positive 4. Now, are these alliances or wars? Well, in each case they're an alliance. These are all positive, so 2x's plus another x is 3x, and 5 plus 4 is 9. And then for our last step, we're going to go ahead and divide. So divide both sides by 3. And we wind up with x equals 3, which is consistent with our answer. Now, how do you know your answer is right? You don't have to wonder. You can take this answer and plug it into each side of the equation. If you get the same result, then you know you did it right. Let me clear that out. So I'm going to take 2, and in place of x, I'm going to put a 3, and I'm putting it in parentheses, minus 4. Whenever you substitute something in that is next to something, you want to put parentheses around it. Well, what do we get? A 2. Well, what if we did that over here? 5 minus 3, also 2. So if I plug 3 into either side, I will get 2 as my outcome. So these are indeed equal to each other. This is the correct answer. Alright. So the remaining part of the lesson, these 6 problems here are just review of solving equations, so there's more problems like this. So I want you to go ahead and work the remaining 6 problems, and in the next video I'll have the answers to those.